Optics Express, Volume 27, Issue 4, page 4758 through 4768. And this is the year 2019. I got this off the internet. I Googled it. Stern-Gerlach experiment with light separating photons by spin with the method of A. Fresnel. Okay, Fresnel in 1822, very long time ago, took quartz crystals, 3 of them, of alternating polarization, and actually separated a right-hand spin from a left-hand spin of photons. Now, we're not talking about electrons like most of the experiments we see today. When we look for spin and we try and look it up on the internet, it almost always sends us to electrons, and they're using electromagnetic frequency or electromagnetic effects to split photons. Here we're using quartz crystals, and the methods to actually split the photons are unknown inside the crystal. So the mechanics of it, the mechanics of splitting photons is pretty much unknown. The main issue is polarization, and physics has polarization very, very wrong. The spin of a photon, the directional spin of a photon, has absolutely nothing to do with polarization. Where this mistake comes from is actually from A. Fresnel, when he discovered the right-handed and left-handedness spin. Let's see here, I will quote this article. Into its right and left circular polarization components. This is completely and totally incorrect. It is the right hand and left hand spin of the photon, has nothing to do with polarization. Polarization has to do with timing of a photon, timing of the actual spin of electrons, and actual spins of the atoms. It has absolutely nothing to do with the spin, with the direction of the spin. It has to do with the frequency of the spin, both photons and electrons. We have an electric field and a magnetic field here, and they are on the XY axis, and this is an old way of thinking of it, and it's pretty much a standard way of thinking of it also. So as a photon goes by, we have a positive and a negative on both fields, and we're keeping them separate in the XY axis. So it's easy to come to miscomprehension that as the photon goes by, that these waves go by in the XY plane. This is a bad idea. It's unproven, and I'm going to go back to a graduate physics course that I had at NC State. The book we were using was Hecht second edition Optics, copyright in 1987. And again, I'm putting a more accurate link below as to what is more likely to be true. And there is a range, and I'm going to pull a quote out of this book. There is a range of situations in which the detecting equipment is such that it is impossible to distinguish individual quanta. That means they are not getting this form from a single photon. They're getting them from lots and lots of photons. In order to figure out where the electromagnetic effect is coming from, it requires that energy be given into a detector. You cannot detect anything without energy. So we're going to go to another possibility of how photons actually interact. If you go to the site that I have linked below, then it's going to give you a better picture of it than what I gave you. Here I'm coming off the x-axis, here I'm coming off the y-axis, this being x and this one being y, and z going out this direction, as in the direction of the motion of the photon. So what we're seeing on it is that these two waves are not split in half, they're split in quarters. And One of the things that I do believe they messed up on was they called this one a right hand, and I'm using my right hand would show it this way. But as you can see, the swirls are going this way. So if I point my thumb in the direction of the motion and curl my fingers around the direction of the motion of the fields, then I'm getting a left hand. So I'm putting a question mark near there because from my point of view, I don't get the same thing that they got on the direction of spin. If I go to my vortex model of the photon, where I have two vortexes, we're going to call this the center point of the photon coming out. The direction of it is coming towards the camera. And we have spins of the photon, spins of the two quarks, or in this case, I'm going to rename them vortex waves just because quarks use their own. The term quarks generally refers to the same item but working in different ways. So as they spin, they're going to put a force downwards, and a clockwise would take these and would make these two vortex waves spin around the center of its direction, the central point of its direction. So this would give it a an offset of the plus and minus, and would match the link that I put down below. When we look at polarization through a helical antenna, these are basically the attributes of the helical antenna. The polarization would change depending on these attributes. So if you change the diameter of the helical antenna and try and receive it with a different diameter, that you will not quite get the same results or get very poor results. I believe that they have to be synchronized, as in all of these, as in diameter, circumference, vertical separation. Usually the helical antennas will come out and they will spin, and I believe they spin 3 times. It may be 3.5, but there is a set number where you get maximum communication capability with those two types of antennas. And also a right-hand turn, I'm going to say clockwise, so it's turning clockwise as in the direction it's pointed, has a completely different polarization than the counterclockwise spin of it. I got it from antennatheory.com, and it is copyrighted. So this particular part of information I was able to get from other places too. So if I'm just hoping that I did not infringe on any copyrights on this one. My conclusion is down here, and it is an idea, and I have nothing to back it up with really, other than what I'm going to be going over with next. Okay, looking over antenna polarization rather than lensing polarization, this is where we're talking about radio waves being polarized. If you look at a vertical antenna, it creates huge quantities of photons at every single dot. So what's happening is, as electrons are being pumped into the antenna, and that is a positive pumping of a negatively charged electron, or electrons by the hundreds. What's happening is the compression point is getting bigger and bigger, which means every single electron is accelerating at the exact same speed all the way up until the wave ends. And that's all it does. There's no return on the electrons. So these electrons are actually accelerating up this thing, and as they accelerate, they're also radiating, the electrons themselves are radiating downwards towards the ground. What this does is it produces photons, and these photons have a size that's smaller than the wavelength. According to the theories that I'm working on, the electrons, or the photons, are smaller than the wavelength. So from this, I'm going to go at one particular point on here and saying that thousands and thousands of photons are being radiated this direction, but only the ones that sync up from here to here are actually being received, as in these, the photon that is being received here produces a wave front that is the same electrical wavefront that has been induced through this antenna to create the photons. Photons hit here, they're absorbed, and through that absorption they're creating an electromagnetic wavefront. They're actually creating a wave motion within all the electrons on this particular wire. And that goes back down to here and creates a radio, or a radio reception. And do remember that, say, 100,000 watts goes out here, but yet it has to be amplified just to get a single watt through here. So it's very small energy that's collected. If you go from a vertical to a horizontal, this system, there's no alignment that aligns this one to here, this photon to here, this photon to here, this photon to the other end of the antenna. The electrons spin around the atom. The synchronization of that compared to the synchronization here is in sync. Then it's not going to say, okay, we have a small piece of charge going here. Say we have the wave. So we have a charge here going along the wave, and on this side charge here. Oops, going the wrong direction. And each photon from here hits here, and that creating a wave or a motion within the electrons. That's not happening. And that's how we get the polarization effect, or lack of polarization. Another type of antenna, you might have seen them on old TVs, is where you have a wire that's in a round shape, and this is a closed loop, so it's not using a ground. Whereas airplanes and boats are using the shell of the airplane or the hull of the boat as their ground. This one here is its own ground. So what's happening is we can have an antenna this way. We can put an antenna between two trees and go horizontal. And in either case, it's a matter of turning this antenna in a direction so that we have an alignment, whether it be, say, make this part align with this and turn it so that this one here no longer aligns. And that way we have a very small amount of wavefront that's being created here that is taking all these electrons and moving them back and forth, creating electricity that is read by the radio or television. Okay, if we're on a ship, and this is where you can use this exact same wavelength. You have one antenna vertically polarized, the other one horizontally polarized. And if these antennas are facing each other, you can use the exact same frequency to send two different signals, and those signals will not interfere with each other. So again, in 1822, Fresnel associated polarization with the spin of a photon, and that is whether it be left hand or right hand spin of a photon. And this is what I am going against right now. Again, I've got a video link below that gives an idea of how the charge in a photon works. And right now I'm going to be looking at the electrons. So I'm going to say that the electrons have either the electrons or electron orbits have a synchronization. I've been working on this idea for over 30 years. When I was a professional photographer at age 13. And the first time I saw polarization, the first thing that came to my mind is, no, that's not how polarization works. But I couldn't explain anything else. So now I'm coming up with a new explanation, and it's called electron photon synchronization. And I'm saying that the synchronization from here to here is going to be virtually the same as one from here to here, one from here to here. As we move the antenna back or move it down, this direction here is going to change. So it doesn't matter how the photon-electron interaction happens here, just so long as it goes around that from here to as it goes up, and the direction of the electron synchronization goes in a circle, and it goes by the speed of light, that it's going to create photons in this direction with a different synchronization. So as it goes up, this, and if I have it going in this direction, the synchronization, the spin, synchronized spin, so instead of going this direction, it would, let's see here, this one would be in the opposite direction, that one about here would be in that direction. So as you go up by the speed of light, by the wavelength of the particular photon being created, and this controls the wavelength. I still can't remember if this is half or quarter, but it's too early in the morning and I'm just not going over it again. Anyhow, I was thinking of lining the photon or electron alignments up this way as in a lattice form, but it is far simpler to look at it from a linear form, and this is electron synchronization. So if we have electrons next to each other and they have a magnetic synchronization as into where the electron is in relationship to the nucleus of the atom, then I'm saying that if an electron is on one side of the atom, then it's going to force the electron next to it to be equivalent, and equivalent, and equivalent, and equivalent. So the spins are going to have some equivalent forces. So from here to here, 1, 2, 3, 4. If I go out 4 electrons, I'm going to declare the force as 1. If I cut it in half, go from here to here, the force is not twice as much. The force is 4 times greater because it runs under the 1 over r squared rule. That is the electromagnetic effect does. So does gravity and all bunch of other effects. But anyhow, if I go from here to here, it is 16 times greater force, synchronization force, as from here to here. So what I'm saying is that it's like putting a lot of pendulums on a board that vibrate back and forth. They will auto-align the synchronization. So I'm saying that the electrons from here to the other side of the planet, by the time this video is through, have synchronized with themselves and are in synchronization, so that any photon being created here is going to be in synchronization with the synchronization of the electrons. And that is where I am getting polarization from. I am not getting it from the actual spin. Or I shouldn't say that. I should say it that I'm not getting it just from the spin of the photon. I'm saying that the direction of the spin, whether a photon is coming this way and has a spin that is clockwise, or a photon that is this way and it has a spin that is counterclockwise in that direction, makes no difference. I'm saying that it is the actual wavelength of the photon, the synchronization of that wavelength to the synchronization of the electrons that make up polarization. And that is the reason why I feel that when you have a polarizing lens, that it is the actual atoms that are creating a, I guess an antenna or a photon trap, electromagnetic trap. So it is trapping the electromagnetic aspects of the photon into a resonance chamber, and if that resonance chamber is there, then it acts differently than if that resonance chamber is not there. This might be a very bad video, but I'm putting it out anyway. See you on the next one.